Hello everyone, and today is the third part of particles in this series. Today we will do a drill, a very common drill that every artist go through when they learn about particles. So this is the very fundamentals of how particles work, and today we will use GeoVOP, the node that we used in the last part. In the last part, we guided our particles towards a point, right? And in this video, we will do the same, but we will do this by cross product, and we will like move those particles in a circular motion, the same way that a pop axis force does. So this is really important. If anyone learning particles, this is the very fundamentals. If you go through this, then you will have the basic understanding of how these extra nodes work. And let's just jump into the video. And you see I have this empty geo container. Let's create a torus. I have this torus right now, and let's decrease its radius, its inner radius, and its uh, wait a second. Yeah, we have something like this. This is a simple torus, a simple SOP geometry. Connect a pop network. So this is a DOP node in which inside we have uh, pre-built nodes for us. This is just the way we created our nodes when we created our DOP network. So Houdini has this shortcut that we can create the pop net. This is just basically a DOP net. I have talked about this in the last two videos, and I can turn off the guide, and we have the particles, which is usually scattered onto the surface if we create the pop net directly. So we have the particles. If I turn on this, I have the particles, and they are like sampled by each frame. So we have particles importing per frame. And what I want to show you here first, let's create a pop axis force, and you will understand this when we connect this to this. I have this reddish thing over here. This is our handle. This is our handle of this pop axis force node. This pop axis force is creating some force inside this handle. So I have the orbit speed. This is giving it an orbit force, and by this orbit force, these particles will revolve in a circular motion. So by this orbit force, these particles will revolve in a circular motion. When I play this, you will see these particles are rotating, right? So there is a force that is being applied onto these particles, and you will ask, when we have orbit speed, why they are going like out of this handle, why they are not rotating in just a circular motion? And this question is really important to answer, because this is how the forces work in Houdini or any real simulation. To answer this, I will have to create a diagram so you can understand this better. So we have these particles, this torus, and we have particles right here. So I am giving an orbit speed right there. So you see these particles are getting a force, and when you zoom in this, you'll see we have these particles, and they are getting a force, and they are moving in this circular direction. But here the catch is, the force is giving them a velocity, and this velocity are making them move slightly out of this circular motion. So they are now here, and they will get another force in this direction, and they will slightly move outside again. They will move again, and they will move again. So if I were to create this again, you see we are getting this. So this slight deflection from their path is why they are going something like this. Now we understand this why they're moving because of the force. And I have this lift speed, right? Lift speed is what this is a force that is being applied in the y direction. When I say 1, you see these particles will move in the y direction, right? Okay. And we have the suction speed. You see, if I just give the 0, and you see the suction speed here is because what this can do, these particles are moving outwards. So if I say positive suction speed, that means these particles will be sucked towards the center. When I play this again with this suction speed, you see they are now rotating, they are pushing towards center. But what is happening again here? We have two forces are being applied onto these particles. We have orbit speed and we have suction speed. Orbit speed is like greater than the suction speed. The suction speed will work, but it is out outvalued by the orbit speed. That's why they come inwards. Then the orbit speed larger than the suction speed. That's why they are going outwards again. If I say suction speed is greater than the orbit speed, they won't go outwards because here suction speed is powerful, right? You see something like this. And why they are not coming at the very center? Because you see these forces are working against each other, so they are cancelling them out at this point. So we have the suction speed. If I say lift speed 1, they will move upwards and inwards also. And when they are outside uh, of this handle, you see no force is being applied. The velocity they were moving with will exist and they will move in this position. So this is the pop axis force we have by default, but this has its limitations. You know, in bigger projects we don't use these pop axis force much because this don't give us more freedom than we can have by creating on our own forces. This is really helpful. This can work sometimes, but not really. So what we can do, we can bypass this and we can create our own force, which is GeoVOP. GeoVOP. So GeoVOP here is the VOP node. We are writing VEX, but with nodes, it is like the same attribute VOP node, but this works inside the dynamic operators. And we have these two input and output. What we can do right now, we only have these particles for now. And let's give this some visual interest so we can understand this better. Let's give a pop color node and go in source, and let's say life expectancy to 5 seconds, and let's say constant birth rate 5000 is okay, and seed I can say ff means either here frame rate. So when we increase the frame rate, you will get the same value as your frame rate. If I'm at frame 10, you will get the frame rate here the 10. I can do one more thing. We can say $T star 5. $T star 5. What this will do? This will increase the seed value by 5 per frame. This time here is time per frame, and star 5 means multiplication by 5. So we will have random seeds by 5, and now we have something like this. Really nice source values. What we can do in the pop color, just say ramp and say inferno. So we can have something like this. And NH here is life, and life is right now 5 seconds, so we will see the yellow color after 5 seconds, right? I've talked about this in the last to last video when we were first talking about particles, and we have something like this. So inside the geometry VOP, now what our first main goal here is, I want to revolve them around this center. I want to rotate them in clockwise or anti-clockwise, but first we need to give them a velocity around, like, in this direction. So to explain this, how we can do this, we have something really cool here. This is really interesting. It can be complicated also, but this will be interesting. So we have these particles on this torus. We have the center value is 0 0, right? And these particles have their position p. We don't know their position, so let's say they have x, y and z. So we don't know their position, but we can have the direction, right? In the last video we guided the particles towards a point, and we did the same. When we subtract this from this, we get a direction. So let's say this is p1. So when we subtract p1 minus p, we will get our p, which is this vector, and this vector will give you this length and with direction also. So we can have the direction plus length. What we can do now, what if I have this vector? We need this vector, right? We need this vector. We have this vector which is pointing upwards. If I have these two vectors, this vector is pointing upward, and this is our vector which we can get from subtracting these 2 points. So we can have our vector which will be our final vector, and that final vector will be in this direction. And how we can do that? When we cross product these two vectors, we get a vector perpendicular to both of these vectors. And here the right hand rule comes in handy. So if you have your hand something like this, so we have this vector and this vector. So for example, this vector is going up and this vector is going in this direction, and this is going to the center, and this vector is going in the y direction. When we cross multiply these two vectors, we will get this vector. And when you do something like this, you will see how this vector is being calculated here. So this final vector, let's say this final vector will be our vector we need, because this final vector, when we give this directly into the velocity, we can have our, like, circular motion. And how we can do this? We can do this by, we need the center. So I will create a subtract and subtract first input. First we need this 0 0 input. So I will cut this and I will say constant, and this constant here is our 3 float vector, and it is our center of this grid. So when we minus this from the point positions, we will get a vector which is facing towards the center. Because in the last video, when we guided our particles to a point, we subtracted the point position to our particles position, so we can have how much distance it is from there, from this point particle position to the point and in which direction this vector is giving us the same. And when I cross product this, but here our vector, which we have this vector and we need this vector which is facing the y direction, and we can say vector 2 here. You can just simply write it here, or you can give this a constant, but I can just write it here. So here vector 2 is facing upwards, and for this case we need to like have this normalized, so we can only have the direction and the magnitude is 1, so it is now a unit vector. And when you play this, you will see your particles rotating. See, you have your particles rotating, and these particles which are turning yellow means these particles have age 5 seconds here, right? And now what we can do, we can create the same motion as we created with the axis force, and we can add another force which can be a constant value, which is a vector, which would be a vector in the y direction, and you will see something like this, right? You can decrease this constant value by, you can just decrease it from here, or you can multiply with constant and you can decrease its value, right? So we can have something like this. We can have something like this, or you can decrease it more, or you can decrease it directly from here. But what I want to do here, again, you can like multiply, you can increase the magnitude of this vector by multiplying by a constant, and here constant, same thing as we did here. You can just increase or decrease the values from there. So increase the rotational force, rotational speed, velocity here, because the value going directly into the velocity, no force is being applied here, because we are giving the value into the velocity. That's why we have much more freedom here. But if I say 2, they will rotate by double the velocity. You will see something like this. Let's say for now 1, and we have this. This is the setup. This is the drill that I would recommend you that do it by yourself. Draw these vectors or create these nodes, have some variation. And what you can do more, you can add the curl noise, or you can add the turbulence noise here. But the curl noise, we can do the same like we did in the last video. What I can say, I can add a curl noise, or before adding a curl noise, what I can do, I can just give this a pop force, and here for force the amplitude is 0. The force amplitude are 0, but we have the noise amplitude, let's say 0.5, and you will see something like this. I want to increase the amplitude so we can see our motion better, right? I can decrease the swirl size. Okay, we have something like this. Really important question here. When we have force 0, we only have noise, then why these particle velocity are affecting by this when we have 0 force? Really important question, and the answer is here. The noise here is sampling from the force field in this 3D space. We are sampling the force values by this noise. This is a noise field, but noise field here is sampling from this 3D space, and the values are being applied as a force. What do I mean by noise here, force field? You see these two. These are force fields, and these are fields. These have some values. Just like imagine this, these arrows represent a force value here. They have their magnitude and they have their direction. This arrow has lower magnitude, but it has a direction. So these pop force is sampling this noise force, and this is a special force, not special force, it's special, related to space. And these forces are present in this 3D space. We are sampling these. So if this point is located at this position, we are just like reading the value of this force on this position, and we are adding this pop force value towards in like with our velocities. And these force values are being applied onto these points, and these points are getting, after that, getting a velocity, and that velocity is being modified with the velocity we also have. So we have this pop force, and you see the result. We have something like this. So I hope you understand what this is doing. Just turn off this and go inside VOP, and we have this curl noise. And GeoVOP here is acting as our manual. We are creating our velocity and forces manually. Curl noise here, it will do the same. It will read the point position values, and it will assign a force field according to the noise type. We have this curl noise. This is a curvy pattern, like curly pattern in this 3D space. The forces are like spread, something like they are in a curl pattern. Curl noise, let's say a curl pattern, and this curl pattern will be sampled, and this curl pattern will be applied to the points, to these points velocity as a force. But this force will affect their velocity after that, and we will have some motion which will be a curly motion. Noises like separately are a very like different and very in-depth topic. We don't need to know how noises work just to create some effects. If we know how we can use these noise parameters effectively and create our desired result, so we don't need to know how these noise values are spread in space or how they work. Noise is a physics topic, and it can be really complicated because these noise types work very differently, and it depends on how these what is the noise type and what are the patterns. It's really difficult if we go in depth, but we don't need to. We just need to know how these noise values work and what pattern do they create. So this curl noise will create some curl like patterns. And this curl noise here, really important thing here, we have two types of noise, 3D and 4D noise. In the last video we used the 4D noise, and the fourth component was time. Today we will do the same. The curl noise here, first it wants to have the position, because it needs the position to read the force values, right? So we have the position, and you see the 4D noise option just disappeared. It's just grayed out. And what is happening? Because to get the 4D noise, we need to have the position vector in 4 dimensions. We have the 4 component position vector here, and we can convert this vector into vector to vector 4 by the 4th component. We can have our time. So now we have the 4D noise here. So this 4 component vector and the 4th component, which is W here, X, Y, Z, and W is time here, and time, now we have 4-dimensional noise. And what this means, in the last video I explained this, but I will explain it again. So the 4th component is time. Now we are reading the value at a specific time. When we are at frame 1, we are reading the value of frame 1. Then the values, these noise values, are changing, but in a way like they are changing smoothly. That's the fundamental concept of curl noise. These values are changing. The motion is like really smooth curly motion, and the like values in the second frame will be different. Now we will sample the values uh, in second frame, then third frame. So here time is also a component. We are reading the noise values, like it also depends on time, at what time we are reading the noise values. So we can have some more random values. So now we have a 4D curl noise here, and what we can do, we can add this curl noise directly into the input 3, and we can have something like this. This is the fundamentals of curl noise. I can decrease the amplitude, let's say 0.5, and we can have something like this, or I can increase or decrease the frequency. Let's decrease the frequency 0.73, and we can have something like this. I want to like increase the rotational speed here. We can say 2. So now the rotational speed here is faster, right? And we have something like this. And you see the curl noise here is giving us this pattern, this smooth pattern, these curly patterns. And we have roughness, amplitude, turbulence, attenuation. We don't need to understand these because we are understanding particle right now. And what I want to tell you here, that the subtraction we were getting, we were getting a vector that points towards the center. That means we can use that value, use that direction to move these particles, to guide these particles towards center also. What we need to do, we just need to have this component here and give this into the input 4 of this add. So now we are adding the force, we are adding a force we are adding a value into the into this vector component here also, which will guide our particles towards the center. And you see, now we are seeing something like this here. And really important thing, you can increase or decrease this force by simply multiplying a constant. You can multiply this and say, I want this force greater than the circular force. You can have something like this, or you can decrease this force. See, they are moving towards the center, but not that strongly, right? We are seeing something like this. So I guess, hope you understand this. This is the drill that every artist must go through, and you see this drill in many like tutorials. When you will see like Vox tutorials or Rebelware tutorials, you will see they create something like this, because this is like the fundamentals of the particles. So this is the basic, like we create when we working with the like SOPs, when we started with our modeling and we created the procedural tower, the procedural bridge. These are some drills that like every artist go through when they first start learning about particles or learning about geometries. So I would recommend you that you go through these notes step by step, and you understand this, what is happening here. And I just remember this thing. What if I want to what if I want to counterclockwise its rotation? I want to change its rotation to clockwise, sorry. You see the rotation here, we are seeing this is when we see it from the top. Let's say right there, when we see it from the top, you see the rotation here is counterclockwise. What if I want to rotate this clockwise? So this is a really important thing, and this can be only done by these concepts, these basic concepts. Anyone can do this if he knows or she knows the basics. So here what we can do to change this rotation to counterclockwise, what we need to do is really simple here. We just need to do the cross product, like We had two vectors and we are cross product we are producting we are doing the cross product of these two vectors and we are getting this vector. What we need to do, we just want to like uh, turn this in the opposite direction and you will get your answer. What we need to do, we just need to change their orientation. What do I mean by orientation? We were cross producting vector 1, vector 2 and we are getting our answer, but in this case what you need to do is vector 2 into vector 1. Simply just flip the product. And here we were cross producting from the vector 1 into the vector 2. What do I want to say? Vector 2, vector 1. And you will get your answer. And why we are saying this? Because the product here is the x direction. We don't need the x direction. We want our vector to be in the y direction. So we can say something like this. And now this is moving clockwise. This is the really important thing. You are just changing the product like in the opposite direction, and you were seeing something like this. Now you are doing something like this, so you have the opposite direction, but the fundamentals are the same. So I guess this is it for this video. We have our drill completed. So I will say, do this again, do this, create this network on your own, understand how each node works and what they do, and you can have the basics of your particles ready. I will create, I guess, two more videos about particles because we have more to cover about these particles. And that's it. I will see you in the next video. And until then, create these and work with these and get familiar with these.